Okay, pre-calculus, in this video we're going to talk about writing equations from graphs and descriptions for sine and cosine. So we're working backwards. We're going to write equations from descriptions and equations from graphs. So this very first equation here, write an equation for a negative cosine curve, so it's negative, it's cosine, it has an amplitude of 6, a period of 90, and a phase shift 45 degrees to the left. So notice that I'm giving you things in degrees. That means we're using theta. So we're going to start out with y equals, well, if this is a negative cosine curve with an amplitude of 6, that means that this is going to look just like that. All right, so we've taken care of all three of those things. The next thing we need to consider is the period of 90 degrees. Well, remember how this works. We consider the parent function of cosine first. So the parent function of cosine has a degree of 360, or I'm sorry, a period of 360 degrees. And remember, we always divide that by whatever's in the equation. So we don't know that right now, but we know that it results in a period of 90. So we have an equation here. So we are going to solve this for x. So when I cross multiply, I get 90x equals 360. I divide by 90, and x equals 4. So that's what goes into my equation right here. And then I've got a phase shift, so that means parentheses. I'm using theta. Theta is plus 45 because it's left 45 degrees. See, not horrible at all. All right, now let's do the same thing for the next problem. Write an equation for a positive sine curve. So positive sine has an amplitude of 3, a period of pi over 2, and a shift down of 2. Notice you're given the period in radians. That indicates that we are going to use x in our formula instead of theta. So I've got positive sine amplitude 3. So that's what that would look like. Remember, the value that goes right here, whatever that is, produced a period of pi over 2. So consider the parent. The parent of sine has a period of 2 pi. It gets divided by whatever is in this equation right here, right after sine, and it results in a period of pi over 2. I cross multiply. X times pi, x pi. 2 pi times 2, 4 pi. I divide both sides by pi. I get 4. Groovy. And don't forget x, because we're dealing in radians. This shift down of 2, no parentheses. You could also write this as y equals negative 2 plus 3 sine of 4x. Those mean exactly the same thing. Okay, so now we're going to look at a graph. The graphs tend to be a little trickier, so I'm just throwing that out there for you. So please keep in mind for the graph, you have to consider if you're using cosine or sine. You have to consider if there's a reflection or not. You have to consider amplitude, the period, and any kind of right or left shift, which is a phase shift, or an up-down shift. So is there a phase shift? Is there a up or down shift? Okay, so you have to consider all of that stuff. All right, the very first thing I am going to do is I'm going to notice my x-axis. All right, my x-axis consists of radians. So notice that this right here is negative pi, and this right here is negative 2 pi. That means every 2 spaces here is going to be half a pi. So negative pi over 2, negative pi, negative 3 pi over 2. And then here, pi over 2, pi, 3 pi, if I could write, over 2, and then 2 pi. Okay, so I want that noted first. So we are going to be in radians, so we're using x instead of theta. So that's the first thing. All right, the next thing, I want to note the amplitude. So if you will notice up here, all the way down here, that is 8 spaces. That means my amplitude is 4. So if you will consider this, this is going to be the center of my graph. That's going to help me identify how it's drawn, okay? So having said that, let me use my highlighter here. If you're considering the sine function, all right? And I'll just use this sine function. Remember what the sine function looks like. This would be one cycle of the sine function. So if I'm considering that as the sine function, several things have gone on here, right? So the first thing I need to consider is this idea that it has moved. So I need to consider movement. I need to consider, okay, was there a reflection, etc., etc. So I need to look at all of this. So the first thing I'm going to do is talk about the period because it's easy. Notice that if I am going from here all the way to here, and that's one cycle, notice where it goes. It's from negative 3 pi over 2 all the way to pi over 2. That's an indicator that the period is the parent function period. That's 2 pi, all right, because I'm counting 1/2, 2/2, 3/2, 4/2. So that is a total of 2 pi. So the period's taken care of and the amplitude is taken care of. So now I have to consider, okay, what else is happening here with my sine function? Well, think about it. The parent would have gone this way, right? Okay, it would be up there. So what's happened is I have shifted this, okay? This has shifted right here, and it has shifted down. So you can think of this as a shift over to the left and as a shift down if you want to. So let's start with this. Let's look at y equals, and I've got 4 times the sine. So that takes care of that. The period is pi over 2, or sorry, 2 pi. So there's just not going to be anything there, okay? And then x, so I have to consider which way did this shift? Well, it shifted from my origin over to negative 3 pi over 2. So that means that this is going to be positive 3 pi over 2. And then it shifted how many? It shifted 3 down. So that would be my equation for sine. This is not the only answer, just FYI, because you could have also thought of it as reflecting. All right, it just depends on how you look at the graph, but this is a correct picture of it. Okay, so now let's say, making a mess. So now let's take the approach that it could be cosine. All right, so let's look at what the cosine graph would look like. Well, remember, one cycle of the cosine graph, let's use a different color. One cycle here would be that right there. Okay, so now you have to consider the cosine graph. Well, if I consider that one cycle, you could also think of this as reflecting, see? See, because couldn't it be up here somewhere and then it reflected to there? So you could think of that as a reflection. So negative 4 cosine. And then, of course, we don't have to worry about the period. It's the same for 2 pi. So I've just got an understood 1 there. And then you could just think of this as reflecting and then moving down 3, okay? So that's a way to think of that. Are these two the only two answers? Absolutely not. I will grade whatever you have. All right, so example 4. So let's look at this one. So for this one, let's say that, you know what, I'm going to use the sine graph. That's what I see. I see the sine function, okay? So I'm going to use sine, and it looks like it has moved from the origin down to negative 2, so down 2. And the amplitude, if I could spell amplitude, I have trouble with that word for some reason. Okay, so the amplitude, so the measure from here to here is 3. And the period, again, it takes 2 pi to get to a full cycle. So the period is going to be 2 pi, just like the parent. So that's everything that's happening here. So y equals 3 sine of x, because again, on my x-axis, we have radians. So I've got x and then down 2. Okay, so say you don't see the sine function, you see the cosine function. So let's change our color up here. And we will look at it as if it is the cosine function. Well, remember, the cosine function is going to be from the top here all the way down. Oh, I should have used my highlighter. So here, this would be one full cycle, right? Okay, so clearly what has happened here is the cosine function has moved to the right, okay, because normally doesn't it occur up here? So it's moved to the right. And how far has it moved to the right? It has moved to the right pi over 2. But it has also moved down. So let's see how far it has moved down. The amplitude is still 3, right? So that means that this right here has moved down how many? It has moved down 2. All right, so what would this look like if it were cosine 3 cosine x minus pi over 2, right pi over 2, and then down 2. See, not horrible at all.